We are beginning second module. Today we are going to discuss the topic software process framework, in which we will learn CMM model, that is capability maturity model. Before starting module 2, let us understand the syllabus topic in module 2. Initial topics are process framework related models. We will discuss capability maturity model CMM and ISO 9000 model. Then we will start our discussion about the different phases of software development. We will discuss phases such as requirement analysis, requirement elicitation, and analysis principles, then software prototyping and specification. All these phases are part of requirement collection or requirement engineering process. So let us see module 2 in detail. Software process framework. A process framework establishes the foundation for a complete software process by identifying a small number of framework activities that are applicable to all software projects, regardless of size or complexity. It also includes a set of umbrella activities that are applicable across the entire software process. Some most applicable framework activities are described here. Framework activities are work tasks, work products, milestones and deliverables, and quality assurance checkpoints. The framework described in the generic view of software engineering is complemented by a number of umbrella activities. Typical activities include software project tracking and control, which allows the team to assess progress against the software project plan and take necessary action to maintain schedule. Then risk management activity assess the risks that may affect the outcome of the project or quality. Software quality assurance activity defines and conducts activities required to ensure software quality. Formal technical activities or formal technical review activity uncover and remove errors before they propagate to next action. Then measurement activity defines and collects process, project and product measures that assist the team in delivering software that meets customers' need. Then software configuration management manages the effect of change throughout the software process. Reusability management defines criteria for work product reuse. Work product preparation and production encompasses the activities required to create work products such as models, documents, etc. Following generic process framework is applicable to vast majority of software projects. Communication involve heavy communication with the customer and other stakeholders and encompasses requirements gathering. Then planning describes the technical tasks to be conducted, the risks that are likely, resources that will be required, the work products to be produced, and a work schedule. Then modeling which encompasses the creation of models that allow the developer and customer to better understand software requirements and the design that will achieve those requirements. Then construction combines code generation and the testing required, uncovering errors in the code. Then deployment deliver the product to the customer who evaluates the delivered product and provides feedback. Elements of a software process improvement SPI framework can be represented with these four processes, that is software process, assessment, improvement strategy, and capability determination. Based on the assessment of software process, improvement strategies are decided and capability determination are decided, which determines further improvements or the maturity determination of the software process. Each of these four elements of an effective software process can be defined in an effective manner. An existing organizational approach to software development can be assessed against those elements. A meaningful strategy for improvement can be defined. The SPA strategy transforms the existing approach to software development into something that is more focused, more repeatable, and more reliable. An SPA framework defines 1. A set of characteristics that must be present if an effective software process is to be achieved. Then 2. SPI framework defines a method for assessing whether those characteristics are present. Then 3. SPI framework defines a mechanism for summarizing the results of any assessment. And 4. SPI framework defines a strategy for assisting a software organization in implementing those process characteristics that have been found to be weak or missing. Students, we all have heard about CMM level companies. All good companies are CMM level 3 or above standard companies, capability maturity model. Now we are going to understand what is this CMM level companies. CMM is a strategy to improve software process irrespective of the actual life cycle model used. It is not a software life cycle model. Capability maturity model CMM developed by Software Engineering Institute SEI of Carnegie Mellon University in 1986. CMM is used to judge the maturity of software processes of an organization and to identify the key practices that are required to increase the maturity of these processes. There are 5 levels for this capability maturity level in CMM. This provides a measure of the global effectiveness of a company's software engineering practices and establishes 5 process maturity levels. Let's understand these maturity levels. Level 1 is initial CMM level. This is the lowest level. No sound software engineering management practices exist in these level 1 companies. Everything is done on ad hoc basis. Success of the project in this type of companies is based on the competency of the manager and a good software development team. Normally, time and cost overruns in CMM level 1 companies. So most activities are responded to crisis rather than pre-planned tasks. So in level 1, software process is unpredictable. When stuff is changed, process is also changed. Improved process of CMM level 1 companies is CMM level 2 company. We call it with the keyword repeatable or maturity level 2 companies. The policies to manage projects and procedures to implement those policies are established in level 2 or CMM level 2 companies. Management is based on the experience with similar projects. It allows to organize or to repeat successful practices developed on earlier projects. An effective process can be characterized as practiced, documented, enforced, trained, measured, and amenable to be proved. There will be methods to measure the software development related activities so that risk or crisis or corrective action can be planned and prevent from becoming crisis. For example, tracking of cost or schedule and functionality. Software project standards are defined based on previous projects and organization ensures that it is faithfully followed. In conclusion, level 2 organizations are disciplined with control over projects with realistic plans based on the performance of the previous projects. Next higher level maturity level is CMM level 3. We call it as defined level. CMM level 3 is a standard process for developing and maintaining software across the organization. It is documented with this standard process. Software engineering and management process are also documented. The process established at level 3 is used and changed whenever it is appropriate to help the software managers and technical staff to perform more effective way. Organization-wide training program is implemented to ensure that staff and managers have the knowledge and skills required to fulfill their assigned roles. We can summarize level 3, CMO level 3 as organizations with standard and constituent. Within established product lines, cost, schedule, and functionality are under control and software quality is tracked. Next higher level is CMM level 4. We call it as managed level of CMM level 4 companies. Here organization sets quantitative quality goals for both software products and processes. Projects achieve control over the products and process by narrowing the variation in their process performance to fall within acceptable quantitative boundaries. For example, one measure could be the number of faults detected per thousand lines of code. A corresponding objective is to reduce this quantity over time. Level 4 organizations are predictable. Organizations can predict the trends and product quality, and if it goes beyond the limit, action is taken to correct the situation. The highest level mature company is CMM Level 5. The keyword to identify such matured company is with optimizing companies. The entire organization focus on continuous process improvement. It performs SWOT analysis, that identifies the strength, weakness, and opportunity, and threats analysis to identify the weakness and strengthen the process proactively with the goal of preventing the occurrence of defects. Innovations that exploit the best software engineering practices are identified and transferred throughout the organization. Level 5 means continuously improving companies. When we consider these five maturity levels, there is an advancing from the lowest level to the highest level. Advancing a complete maturity level usually takes from 18 months to 3 years, but moving from level 1 to level 2 will take 3 to 5 years in most of the companies. The Software Engineering Institute has associated key process areas KPAs with each of the maturity levels. The KPA describe those software engineering functions that must be present to satisfy good practice at a particular level. Each KPA is described by identifying the following characteristics: goals, commitments, abilities, activities, methods for monitoring implementation, methods for verifying implementation. So now we are going to discuss KPA, key process areas. Except for level 1, each maturity level is decomposed into several key process areas that indicate the areas an organization should focus to improve its software process. At level 2, we are trying to establish basic project management. So, requirement management, software project planning, software project tracing and oversight, software subcontract management, and software quality assurance. Then software configuration management, that is maintaining the integrity of product of the project, are the major key process areas at level 2. Key process areas at level 3 is to address both project and organizational issues. So the various KPAs: 1. Organization process focus, 2. Organization process definition, 3. Training programs, 4. Integrated software management, that is integrate software engineering and management activities with coherent defined process. Then 5. Software product engineering, consistently performing with quality, that is what we are doing in software product engineering. Then 6. Intergroup coordination, that is to improve quality by mixing different engineering groups. And finally, peer reviewing. Key process areas of level 4 focus on establishing a quantitative understanding of software process. So, key process areas include quantitative process management and software quality management. Then, level 5 key process areas. Level 5 is to cover the issues that both organization and project must address to implement continuous and measurable software process improvement. So, technology change management and process change management are the key process areas in level 5. Please note that KPIs are additive. For example, Process Maturity Level 4 contains all Level 3 KPIs plus those noted for Level 2. Each of the KPIs is defined by a set of key practices that contribute to satisfying its goals. The key practices are policies, procedures, and activities that must occur before a key process area has been fully instituted. The Software Engineering Institute defines key indicators as those key practices or components of key practices that offer the greatest insight into whether the goals of a key process area have been achieved. Assessment questions are designed to probe for the existence or lack thereof of a key indicator.